Good morning, this is your Stat Sensei, Mr. Spensei, and this is an exit ticket. It's a review of the empirical and the normal. So using the scenario on the graph below, illustrate the empirical rule. You must show 3 standard deviations above the mean and 3 standard deviations below. Below the mean, it says above twice. You must clearly label the z-scores and the actual values and the standard deviations. So let's go ahead and start with z-scores. All z-scores, all z-scores have a mean of 0. So we're going to put mean here and say, hey, all z-scores have 0. And 1, 2, 3, that's 1 standard deviation, 2 standard deviations, 3 standard deviations. And we'll go down -1, -2, -3. Now, technically, this goes all the way to negative infinity, and this goes all the way to positive infinity. And we're going to put in here a z because these are our z-scores. Well, we're supposed to be illustrating the empirical rule, so plus or minus 1 standard deviation. By now, we should know pretty confidently that that's 68%. Plus or minus 2 standard deviations. And by the way, that plus the empirical rule only applies to the normal. Plus or minus 2 is 95%. And then plus or minus 3 is at 99.7%. Now, the empirical rule does apply to all normal distributions. All right, so if it's normal, plus or minus 1 will always be 68, plus or minus 2, 95, plus or minus 3, 99.7, regardless of what the mean and standard deviation is. So the resting heart rates of adults in a fitness center are normally distributed with a mean of 70. All right, and a standard deviation of 8. So that means I have 8 between each one of these, regardless whether I'm going up or whether I'm going down. So 70 plus 8 is 78. Add 8 more, and I get to 86. Add 8 more to that, and I get to 94. Taking away 8, I drop down to 72. Take away 8, I drop down to 64. Um, oops, not 72. Wow, this should be 62. Excuse me. 62. This won't be 64. This will be 54. And then take away another 8, and we'll be all the way down to 46. So 46 plus 8 is 54. 54 plus 8 is 62. 62 plus 8 is 70. 70 plus 8, 78. 78 plus 8, 86. 86 plus 8 is 94. So that works out. All right. So it says what percentage of participants have heart rates between 57 and 675 beats per minute? So what we're looking for here is the probability that 57 is less than X is less than 75. So that's what we're looking for on this question. So if I'm drawing a picture of it, which you all need to do, do so much better every time you do it. The mean is 70. All right, so that's where we're centered at. We're always centered on the mean for a normal. Well, 57 is below this, and 75 is somewhere up here above it. So I'm looking for those values, and this is my lower, and this is my upper. As we've done before, we're going to go norm CDF. And we have a lower bound of 57, upper bound of 75, a standard deviation of, where did it go? A standard deviation of 8, and we had a mean of 70. So 70 and mean of 8. And by the way, if you can't remember those, and I just had trouble remembering the order, just go second vars, norm CDF, and the calculator tells you it wants lower, upper, mean, standard deviation. So always just plug them in that order: lower, upper, mean, standard deviation, or LUMO. So our lower bound was 57, our upper bound was 75, our mean was 70, and our standard deviation was 8. And I end up with 0.6819. All right. What percentage of participants have heart rates less than 57? So we're looking for the probability that X is less than 57. Well, we know our mean is 70, our standard deviation is 8. That hasn't changed. So this normal curve is going to be centered at 70, just like the previous. But we're going to start at 57 as our upper bound. And remember, all normal curves theoretically go to negative infinity. So we're looking for this area. This is technically my lower, this is my upper. All right. So we're going to go back to our norm CDF. With a lower of negative infinity, an upper of 57, a mean of 70, and a standard deviation of 8. So lower, upper, mean, standard deviation, or LUMO. Second vars, normal CDF. Oops, -9 raised to the 99th, because that's the smallest value the calculator will work with. Our upper bound was 57. Upper bound was 57. Our mean was 70. And our standard deviation is 8. And we get 0.0520. All right, the next thing, what percentage of participants have heart rates greater than 75 beats per minute? So we're looking for the probability that X is greater than 75. Well, our mean is still at 70. But now we're looking for a value 75 or higher. And please remember, it goes to positive infinity. So norm CDF, lower bound 75, upper bound positive infinity, mean 70, standard deviation in this case is still the 8 that we had earlier. So this is my LUMO. Second vars, normal CDF. 75, shaded to positive infinity, 9 to the 99th. And we end up getting about 26%, 0.2659. 0.2659. Box that in. All right, next one. Approximately how many of 500 participants have rates between 57 and 75? Well, up ahead, we already figured out that probability, and we're going to need that probability. So I'm going to go ahead and write this out. The probability that 57 is less than X is less than 75, and I'm just getting this from my previous problem, equals 0.6819. I'm going to need that because I'm going to set up a proportion. And my proportion is going to look like X over 500, because I don't know what X is. That's what I want to know. How many out of 500 equals 0.6819 over 1. Well, I'm going to multiply the two numbers on the diagonal and divide by the third. So that's going to give me 500 times 0.6819 over 1. 500 times 0.6819 divided by 1. and I get about 341 equals 0.340.95. So we'd expect about 340.9. All right. Approximately how many participants of the 500 would have less than 57? Well, we already calculated that up here. So less than 57 is 0.0520. So the probability, and we're going to remind ourselves of this, the probability that x is less than 57, well, what did we say that equal? We said it equaled 0.0520. All right, so once again, we're going to set up a proportion. How many out of 500? X out of 500 equals 0.0521 over 1, part over whole. So I'm multiplying those two values. 500 times 0.0521 is 26.05. So 500 times 0.0521 over 1 equals 26.05. All right, and I'm going to go ahead and box this. I'll make one more small chain. There's not supposed to be a decimal right here. So I'm going to make that 340.95. And it's 340.95 participants or 26.05 participants. All right. I appreciate you watching, and I hope to see you on the next one. Thank you.